All right, let's do one last problem. We'll call it a night, or I'll call it a night. So we're going to take and evaluate the integral We're going to evaluate the integral over the region, or I don't know why they call it switch D and R all the time, but we'll say they say R here. Okay, y e to the x dA, where R is in the first quadrant, and bounded by x squared plus y squared equals 36. Okay, so let's go ahead and draw this region out. That's the region we're integrating over. Okay, so we're going to take the integral from 0 to pi over 2, from 0 to 6. Now, y is r sine of theta. E to the x is r cosine theta. R dr d theta. Now, I found it's a little easier. It's going to be a little easier if I actually switch the order of integration. Don't really need to do too much here. R goes from 0 to 6. Theta goes from 0 to pi over 2. And now I'm going to have R, and I'm going to keep it separate for a reason. Okay, because what I'm going to do a substitution. I'm going to say U equals R cosine theta. Du is then R sine theta, well, it gets a negative sign, d theta. Okay, so our integral becomes, well, we get a negative sign from 0 to 6. When theta is 0, cosine theta is 1, so we get r on the bottom limit and 0 on the top limit. This r is still there, but this integral does not depend on r. It's going to be an integral in u. Okay? This is the negative, which we have here, of du. So we have e to the u du. Okay? And then we still have dr going on the outside. Okay, so this integral then, the negative stays from 0 to 6. Still have the r. E to the u from r to 0. dr. So that's going to be, now that's going to be, I'm going to flip it. So it's going to be the integral from 0 to 6 in r. R times e to the r minus e to the 0 is 1 dr. Okay, so now you have to do an integration by parts here, but I'm going to leave that to you to finish off the problem. Okay? All right, that's it for 12.3. I'll put 12.4 notes up, I believe, probably Wednesday or Thursday. All right, see you guys then.